Come, all you moonshiners, if you want to hear.
Well, welcome back. I'm George. Of course, this is Barley and Hops, where we try to unlock all those mysteries and explain as much as we possibly can. To be transparent, we're going to wire up a 240 volt PID today. Now, this is going to be just simply wiring for 240 volts, not, I got to underline it, not an accessory 120 volt along with it. Okay? That'll be another video all in itself because it's different. But we're going to just wire, if you want a PID that you can plug a 240 volt or 220, however you want to describe it, that you want to plug a 220 volt element into, this is the one for you. So sit back and I'll show you exactly what you have to have, and I'll kind of explain why it's the way it is. Now, I'll also do another video later on, again, setting the parameters and all those things, because they're different. Look, the first thing that I want you to realize is I use two PIDs primarily. Now, people would ask, George, why would you tell everybody how to do this if this is what if you make these and sell them? It makes no difference to me. I mean, again, this is called being transparent. I want you to understand how they're made as well. They're pretty much straightforward, with a few twists, but these are the two that I use. I use the My Pin, that's this one, and I also use the Inkbird. Now, these are two of the same high quality proportional integral derivative controllers. And you can liken it as if you've got two VCRs, one's made by Sony and one's made by Panasonic. They both do exactly the same thing, but their menus are a little different. Maybe their plugs are a little, that's what this is. It's just, they're wired just a little bit different. Their parameters are a little bit different. How you set them's a little bit different. That's all. But they're both exactly the same. All right. So, by the way, yeah, this is important. If you're going to get a My Pin, make sure you're looking for the My Pin TA4 SNR plus K. It's input, and then you see the output SSR. That's what you're looking for. Output SSR. If it's an RNR, well, then that means that the relay's on the inside. You can't use that for a heater element. Okay. And on this one in particular, this is the ITC 106VH. And you'll see that one as well, that its output is an SSR, 12 volt. So, same thing. Let's get down to what we really need to have, okay? So, because I'm going to show you, this is a straight, again, I'm going to say again, 240 volt direct wire, okay? We're going to need a 240 volt switch. Now, how do you know that this is 240 volts? Well, you'll know it because it'll say so on the label. Now, here's the switch. This is the on-off switch, okay? And this one's labeled as a 20 amp, 120 volt / 277 volt AC. Now, what's that mean? So that means that you can wire it as 120 volts if you want to by just using one side. But we're going to use both sides. You see, you'll have a hot wire and a hot wire. We'll explain that in a minute. And then a hot wire and a hot wire. When you turn the switch on, it's on. It connects the bottom and the top, so you got power. Turn the switch off. It separates these two and these two so that you have no power. All right, and of course, a ground plug. Oh, ground lug. All right, you're also, now I could also use, and I'll show you how I do that. You can also use this small rocker on-off switch. This is called a double pole single throw. It's a simple on and off, and you'll see it's got 4 lugs on the back. It's got 2 in the bottom and then 2 in the top. Just convention. Power goes in the bottom, comes out the top. So when the power is turned on, it connects these two, and it connects these two. When the power is off, it separates these two and these two. The same way this works. It's just smaller amperage or less amperage. So we got that so far. You're going to need a 240 volt plug, and you'll notice on these, if you look here close enough, you see where one of them is horizontal and one of them is vertical. And that's just to ensure that you don't plug it into the wrong place. And this is a 20 amp, 250 volt plug. Boom. Oh, yes. Oh, we're going to need a 20 amp, 250 volt receptacle. You see, and the same thing, it only has 2 screws on it, and they're both brass. In electrical switches and plugs, the brass side will always be the hot side, and the silver side would always be the neutral side. But in this particular case, it has 2 brass, which means it's set up to receive 2 hot legs. Okay? And of course, 1 ground lug. All right, and I'm going to mount those to the board so I can show you this real easy. I've got a heat sink mounted right here in the center of the board, and we're going to use a 40 amp solid state relay. This is a DA, which means that it takes DC voltage into the signal to control AC voltage out. Key. I've got some thermal grease. This is called HY400. Look, it comes in a bunch of different names, but we use thermal grease in order to make that solid contact between the heat sink and the solid state relay so that it transfers heat efficiently so it can be cooled. Boom, boom. All right, yeah, of course, I'm going to use some wire. I've got this small 18 gauge wire. I'll show you where that, I've got some 12 gauge wire. And, oh yes, of course, we're going to have the thermocouple, and that comes in a little bag, and I'll show you how that works too. It's polarity specific. And last but not least, the things that you need to see, we're going to use, and I've gone through this once before, but you have 2 options. You've got, this is a 3-wire, 12 gauge cable. And I use 12 gauge wire because, gosh, that's safe. 14 and 16 is a little bit too small. You know, if you're using a 2,000 watt, or let's say you're using a 3,500 watt, you're going to pull enough amps that it's going to make that wire really hot. So you at least use a 12 gauge. Now this is a 10 gauge. And it's, of course, as 10 gauge, as the numbers go down, the wire gets bigger. It can hold more of a load. This one's a 4-wire. Now you'll see the only difference between these two is all the colors are the same except the addition of a red one. So you'd have a hot on the red, a hot on the black, a neutral on the white, and a ground is your green. Now you don't have that red one here. You only have the black, the white, and the green. Hot, neutral, ground. In this case, you can only get 240 volts. Well, in this case, if you had this one wired up, you could get these 2 wires together, make it 240 volts, but this wire and this wire together would make it 120 volts, or this wire and this wire together would make it 120 volts. And there's a reason for all that, and that'll be on the next video. So now we've got our wire and we're ready, our cable, and we're ready to go. Inside your fuse box, you may see something that looks like this. This is a single throw double pole. It's just a double circuit breaker. That's all it is. On, off. And you have 2 lugs on the bottom. Well, there's one there and there's one there. Well, lo and behold, from your circuit breaker, you're going to have one of your hot wires comes from this lug and the other hot wire comes from this lug. Because the way these are designed, they will pull from both left and right side of the box, which means that they'll be 180 degrees out of phase. Because if you have that, when you use those 2 wires together, they kind of create their own neutral. You don't need a neutral at that point. And then you'll have 1 ground wire that goes to the ground lug in your box. Okay? Now that will all come out, and that will wind up, as you'll see, I've got one on the wall right there, right next to the light switch. I'll have a hot, which is going to be the black and the white at this time. They'll both be hot. And I'll have a ground lug. So that means that this receptacle is energized with 240 volts. Now, that 240 volts is limited to 20 amps. If you had 15 amps, and then you've got a 20 amp plug, you got a 20 amp switch, you know, all that stuff. Remember, this is the baby here that it either makes it capable or not. All right, so make sure it's a 20 amp. Now, what if it's a 30 amp? All that means that now you have the capability to provide more amperage than your switch and your receptacle are rated for. And you really don't want to do that, all right? You could create an unsafe environment. Now, there are larger switches, things like, okay, well, that's for another video all in itself. Now, remember that just because you're providing 20 amps doesn't mean that 20 amps is going to run through this. Amperage in a circuit is totally dependent upon the resistance on the end, okay? So if you put something on the end that's only going to draw 16 amps, if you're providing 20, that doesn't mean 20 is going, it's only going to draw 16. And the rest of it's just going to sit around and wait. It's capable of 20, but it's not providing 20, okay? Or it will only allow 20 to pass before it trips, okay? Make sure that's clear. And I bring that up because your controller only draws like a half an amp. So you don't need 12 gauge wire to run this. We'll get to that. All right. I think we've covered just about all our bases with the exception of the fan. Now I've got these small 40 millimeter 5 volt DC fans. And I put a USB plug on the end of it. That's because almost all USBs are 5 volts. Most of them anyway. Even in your computer, they'll put out 5 volts or 3.3. Oh, where else did where's that other piece I'm looking for? I'll find it here in a second. You've got them laying around, okay? You know your phone chargers. In a lot of cases, your small phone chargers, small cubes, are rated to receive 120 or 240 volts. And if you wonder, it'll say so right on the label. It's marked right there. It'll say, this one says travel adapter 100 to 240 volts, 50 or 60 hertz at 0.15 amps. Output 5 volts DC at 1000 milliamps. That's all you need. And now these are designed to be plugged in and left plugged in, so they're great. They're very inexpensive. So, oh yes. So we plug that in, and then when I plug that into an extension cord on 120 volts or on 240 volts, because it doesn't care, it's going to convert that to 5 volts and it's going to operate the fan. So we set that aside. Now, here's where it gets fun. We're going to start wiring this. So give me a second. I'm going to attach everything to the board so we can hold the board up and show you what we're doing. Okay, I got those attached. Let me get some of this white grease out here. This is called thermal grease, and this just makes sure that you've got a good solid contact or connection, and all you do is wipe it on the bottom. Now, sometimes it'll come in a syringe, and you can just push it out. So just spread it on the bottom of your solid state relay, or put it on the top of your heat sink. It doesn't matter. Put it one way or the other. Now, I'm going to orient this, because you'll notice that on this it has a 1 and a 2 pin. That's the AC side, and it has a DC side, which is the 3 and the 4 pin. All right. Now, and another point is that this will handle this. Will control up to 40 amps. Does that mean there's 40 amps going through it? No. We're on a 20 amp circuit. The most that should ever go through this is 20 amps, or up to, and then that thing, the circuit breaker breaks, and boom, you're done. So a 25 amp would work. So they sell a lot of them called 25 DA. This is a 40 DA. Okay, and I'm going to orient this so that my 1 and 2 are facing towards my receptacle. Now, I'll go clean up this mess, because this stuff is messy. And I'll screw that down and be right back. Now, I have pre-cut some wire and put some spade connectors on the end of it, just to be helpful, so you'd have to watch me go through that. Now I'm going to show you what I have here. So far, this is our board. And you'll notice here now, see, this is my 240 volt plug on the end of here. I already attached that. And I have the black wire goes on this screw on the left, the white one goes on the screw on the right, and then I've got the ground, here's the green, goes to the green lug, And then I just jump from there to this green lug. So now I've got a circuit right there, but it's not hot yet. Well, it's not plugged in, but it's not complete yet. So what we have to do now is I have to connect, this is the white, and when the switch is on, it connects this screw and this screw, but I want that electricity to keep going. I want it to go up here. So I will add this 12 gauge white wire from that screw to that screw. So let me get that done. Mission accomplished. White wire from one screw to the next. Now, so I've got my 120 volt leg. When it's turned on, will go from here to here, from here to here, and from here to there. Boom, that's all I need. Now, I'm going to require, you know, we've got the black side, and that's another 120 volts. It's going to go to this screw. But from this screw, I'm going to go over here to the number 1 pin on the solid state relay. Now, I could make it simple. I mean, you know, and I could use the number 2 pin. It doesn't matter. Electricity will go either that way or that way. But it's easier if you just keep things in order. Okay, it's just like I use the left side for black and the right side for white. I'll do the same thing up here and anywhere I use that. Okay, so now I'm just going to hook my other 120 volt leg that goes to the solid state relay. Okay, top screw to the number 1 screw on the solid state relay. We're almost there. Second black wire that goes from the number 2 pin to the other side of that switch. Now, keep this in mind. I could have gone from here directly to there, right? And then when the switch is on, that means that electricity is running in, out, in, and that would have been hot, okay? I've actually done that, but I've put another switch. That's what a solid state relay does. It acts like a switch, but a smart one. So now it goes in, out, in, out, in, and it stops until that red light comes on. So when I signal this to turn on, it connects here, and then this one goes to there. That is how you energize the element. Right. So now that's it for the 12 gauge wire. We don't need any more 12 gauge wire anywhere. Have you ever tried to wire the 12 gauge wire on the back of a PID? Whew. Ain't a whole lot of room. I'm going to need just a little bit of wire, and I usually get a little bit extra, and because it's easier to cut off because you can't add. So my next step was I need power for the PID to actually operate, and remember we also need power for the fan. So here's what we do. Now why? Here, I'll ask the question. Why switch the highest amperage when you just switch the lowest amperage? Yeah. See, here's what I did. I took a jumper wire. I just went from the hot leg on the left side and the hot leg on the right side. Now I'm using red and black. And so remember I always said, you know, if you start left, stay left with black. So I've got black and then I've got the red on the right side. So what I've got is now I could have hooked it down here, but that means that as soon as I plugged it in, then my PID would come on. I didn't want that to happen. I want it to only happen when I turn the switch on. Yeah, that's what I want it to happen. So I got a red and a black connected together on a small spade that's going to go to the back of the PID, and I'll show you that. And so is this one. Now, but the reason I got another pigtail off of that is because I'm going to use that 240 volts, the same I'm going to use to operate the PID to operate my transformer. Oh, this is a beautiful thing when it comes together. Now, all I need to do is determine on the back of the PID which is which. And in this particular case, it says power. Pins 9 and 10. It says power. But you'll notice it's not polarity specific. So what do I always do? My power is always, my black is always the first pin it goes to. And in this particular case, I'm going to put it on 10. I could put it on 9 and put the red on 10, or put the red on 9 and the black on 10. It doesn't matter at that point. Because, just remember, you know, because they're both going like this, and they make their own neutral. So, unscrew that a little bit, insert black on 10, red on 9, and then screw them down. We're almost finished. When I turn on my switch, my PID is going to come on, and my fan is going to come on. Simple as that. Let me turn the switch off. It's not even plugged in, but I turn the switch off. What do I have left? I still got to operate this. So I need that 12-volt signal from the PID to this. So I've got 2 more pieces of wire. Whoops. Here we go. Now this one happens to be polarity specific. Whereas pin number 3 is positive. So I'll use red as positive because it's DC. Sort of just like a convention. Doesn't really matter, but I like to follow conventions. And I'll use the black one as the ground, which is the negative. Now, if you look on the side of the PID itself, it'll say SSR. And I'm not going to get it close enough for you on this one. But right here it says SSR, and it says number 8 is positive, number 6 is negative. Number 8 is positive, and number 6 is negative. When the PID comes on, and every time it signals that it needs energy for that element, it'll send that 12-volt signal timed through that solid-state relay to tell it how much power it actually needs. It does it through a timing sequence. So, that way that your element's not on or off. It's either on a little bit, it's on a little bit more, or it's off a little bit more, or it's on a whole lot more, or it's off a little bit. But that's the way it works. It actually works like a pulse width modulator in a way. Okay. Now, what's the last thing that we have missing here? We have no interface or interaction with the outside environment. So we need to know, because we're controlling temperature, we need to be able to track the temperature. It's amazing. If you look on here, it'll say pins 3 and 4, TC, thermocouple. And it also says here that pin 3 is negative and pin 4 is positive. This is also polarity specific. So we'll go over here. Whoops, there it is. Here's the thermocouple that comes with it. Now usually I'll exchange this and I'll add one with a long probe on it. They both work exactly the same way and they're just as effective. But I'll put one with a long probe on it because it's just a whole lot easier to play with. And it'll come with a red and a blue. Red is positive, blue is negative. Remember what we said? We look back here, we go, okay, number 4 is positive. So you connect the positive to pin number 4 and the negative to pin number 3. And there you have it. You have one completely wired PID. Now, how do we know that? Well, let's plug it in and find out. Alrighty then, this is our maiden voyage. Plugged in, you ready? If I turn the switch on, my PID comes on. See there? Now these things always come, the next video will be on, we'll go through the parameters on another video, but they always come set at Celsius, in centigrade. This one's 23.4. Let me grab this. And if I hold on to that, you'll notice that the temperature will change. You have 24.9. It'll start to climb its way up to get to my body heat. 26.8. All right. See, and the set value is 50, so that the red light is on the out. That means it's sending a signal. Here is my fan working, and your fan would blow right on that just to keep it cool. Oh yeah, and you'll see that red light on the solid state relay is also on. So that means it's sending a signal to that solid state relay in order to make that hot. So if your element was plugged in right now, it would be working. Folks, that's it. That is the most rudimentary direct wiring of a 240 volt the PID. Stay with us. We got a lot more to cover though. Happy distilling.